Okay, this is the 2010 AMC 12A, and let's begin. 20 minus 2010 minus 201 plus 2010 minus 201 minus 20. That is 20 minus 210 plus 201 plus 2010 minus 201 plus 20. Two 2010s cancel, 201s cancel, and you get 40. Let's see. Start at 10 a.m. until 3. Each trip there was one fewer than the previous trip. You start at 10 a.m. and you go to the last trip. It starts at 3. So at 10 you have 100. At 11 you have 99. At 12 you have 98. At 1 you have 97. At 2 you have 96. And at the trip of 3 you have 95. Okay. And all these last digits are different except for these two. Let me just add the last digit, see what it goes to. 9, 9, 8, that's 7. That's 7, 4, 0, 5, which end in 5, 585. Sounds right. Okay, let's just do this. This would be 100 times 6 minus 1. This is 100 minus 1, 100 minus 2, minus 3, 4, 5. 1 plus 5, that's minus 15. That's 600 minus 15, 585. Okay, good. Okay, the rectangle. Okay, so this is A, B, C, D. This square. This is 20% of its area. So let's just call this length S. And let's just call this length K. So KS equals okay. That means this length is also S. And this is 20% of its area, so that means KS equals 1/5 of S squared. So K equals S over 5. So that means that AB over AD equals 2S over S over 5, which equals 10. Which the volume must be positive. X over that's just the sign. X is less than 0. This is bad. Negative x squared. Negative x squared will be less than 0. X squared is greater than 0. Negative 2 to the x will be, this term will be positive. This will make it negative. Negative 1 over x. This will be negative, and this will be negative. This will make it positive. It should be D. Let's just check E. The cube root of x. If x is negative, this will be negative. It should be D. Halfway through an archery tournament by 50 points. For bullseye, scores 10 points. You could score these other possible points. She will always get 4 points on each shot. Value for N. Okay, so Chelsea starts with 50 points. Bullseye has 10 points. Every other opponents have 0. So let's just pretend they score 10 on every next shot. It's halfway through. Okay, so there's 50 shots left. So let's just say this opponent for every next move gets 50 shots. That would be 50 times 10, which is 500. That's the opponent. And Chelsea will be 50 plus, she'll get 10 N bullseyes, which is worth 10. And then the rest of hers will be 4 points, because she'll score at least 4. So it'll be 50 plus 10N minus 4N plus 200. Okay, so that means that 250 plus, wait, let me make sure I didn't screw up. Should be right. Yeah, that looks right. Okay. 250 plus 6N must be greater than 500. 6N must be greater than 250. N must be greater than 250 over 6. This is about, okay, let's see, 240 would be 40. This would be like 40 plus 246. It's 41 plus epsilon, where epsilon is less than 1. So that means that N has to be, the minimum N is 42, because N has to be greater than like 41 point something. Okay, that looks right. Okay, a palindrome. X plus 32 or 4 is your palindromes. Okay. So smallest palindrome 4 digits is like 1001 or something. Yeah, 1001. A higher palindrome will be, the next palindrome will be like 1 1 1 1. That's way too big. Okay, so it has to be this. And that minus 32. 9 6 and 969. That's palindrome. 18 plus 6 is 24. 24. Okay. Looks good. It's better than, okay. We're good on time. Logan is a scale model of his town. Okay. 40 meters high. Top part is a sphere. His tower holds 0.1 liters. So how tall should you make it? Okay. So volume is factor of 3, which for similarity. So that means that 40 over x, which is the height, must be equal to the cube root of 1000 over 0.1, which equals the cube root of 10 to the 6, which equals 10 squared, 40 over x. So that means that x equals 0.4. Yeah, well, that's right. Okay. ABC, triangle ABC, AB equals 2AC. Okay, so AB, and let's make this AC. A, B, AC. Okay. B, A, E, there's some angle here, E. And that equals A, C, D. Which is on this. BAE, is that right? E is on BC, D is on AB. So ACD, that angle is equal, I guess. Okay. So this angle BAE, this angle equals, this is D, equals ACD. This angle. You want to find angle ACB. Okay, let's make this theta. Let's make this theta. Okay. CFE is equilateral. CF, this is F, is equilateral. It means it's 60, 60, 60, 60. This is 120, 120. Okay. Then, what angle are we looking for? ACB. We're looking for 60 plus theta. We're looking for 60 plus theta. 120 minus theta. Okay, so there should be 60 minus theta. 60 minus theta, 60 plus theta. This is 60. Yeah. I also know this is double this. Wait, this is half of this. So this is x. This is 2x. Could this be 30, 60, 90? Yeah, it could be. This is 120. I guess I should bash a little more first. Wait, actually that could work. This is x root 3, so this is 30. This is 60. 60 is... No, this should be 30 for that to work. Right. Oh no, this is 60. So this should be 60 minus theta. Okay. This is 60. This is x, 2x. Okay, so this is x root 3, and that works. So that means that this angle, this angle should be 30. 60 minus theta should be 30. Theta equals 30. So 60 plus theta is 90. Time is okay. It's been 10 minutes. Okay. Okay, those are the first questions. Just keep that aside. Solid cube, 10 inches. Side length of 3 inches. A 2 by 2 square is come to each face. It goes all the way through. So it would look something like this. On one face. This length 2 is length 3. So that means this is length 0.5. This is length 0.5. Okay. So it would be like this on every side. So you would have a piece that's 2 by 2 and 0.5. Because on this side it's also 0.5. Right? 0.5. Yeah. You would have 6 of those. Which equals 4 times 1/2, 2 times 6, which is 12. Okay, so the area of that is 12. And the area of the inner square is, or the inner cube, 0.5, 0.5. It's a 2 by 2 by 2 cube. Just 8. So it'll be 20. 20 total. And to complementary count, 3 by 3 by 3, the original volume is 27. So you want to subtract 20, and you get 7. Is it right? Did I do this right? It's a 2 by 2 by 2 cube in the center. Yeah, that seems right. Question 10. Okay, it's been 15 minutes. Gotta speed up a little bit. Okay, it's an arithmetic series. Okay, you gotta find the common ratio. So 9 minus p equals 3p minus q minus 9. Okay. So 4p equals 18 plus q. Okay, so q equals 4p minus 18. And we have 3p plus q minus 3p minus q equals 7 minus p. So this would be 2q equals 9 minus p. 8p minus 36 equals 9 minus p. So that would be 45 equals 9p, p equals 5. So 9 minus p, which is a common difference, is 4. Okay, so the first term is p, and you add 2009 times d. So you want 5 plus 2009 times 4. That should end in a 6. Oh, am I being bad? Yeah, it would be 6. Something ends in a 9 times 4 is 36, plus 5, which end in 1. Okay, that looks like this. Let me just check. 6, 36, 0, 8, and you add 5, 8, 0, 4, 1. Okay, good. Okay. 7 to the x plus 7 equals 8 to the x. Log x equals log b 7 to 7, which equals 7 log b 7. So from this we have, if we take the log of both sides, log base 7, log 7 of 7 to the x plus 7 equals log 7 8 to the x. So this equals x plus 7, the log 7 goes away, equals log 7x log 7 8. Okay. So then if I bring the x to one side, 7 equals x log 7x minus 1, which equals log 7 7. 7 equals x log 7 8 over 7. So then x equals 7 over log 7 8 over 7, which equals 7 log 8 over 7 7. So b equals 8 over 7. Okay. There are two species of talking amphibians. Toad equals true, frog equals false. It's probably a contradiction. Okay, so let's assume Brian is true. That means, let's assume Brian is a toad. That means that M is a frog. And you need two of them to be frogs. Chris and Roy. Okay, Chris says L is a frog. L says C is a frog. So one of them is lying. So if C is a toad, then L is a lie. Then L is a frog. And that means this would be true. Leroy's statement would be he's lying, Chris is a toad. So that's what it works. And the reverse is also true. It means one of them is definitely a toad, one of them is definitely a frog. So it means that you have one frog. And then the Brian and Mike. Okay, Brian is true. And then Mike would be saying two toads. So that means that would be true. Right? You would have two toads. There's no logical problem, right? At least two are toads. 4 of us, at least 2 are toads. He's a toad and he's a toad. No problem? Oh no, he's lying. Okay, so if Mike is telling the truth, Brian's telling the truth. Oh wait, no, because if Brian's telling the truth, then if you assume Mike must be a frog then, and that means that then he's saying that there's 1 or 0 toads, but that'd be false because we know that there would be 2 toads from this. Okay, so that means that Brian has to be lying. So that means Mike and Brian are the same. Mike is a frog. Brian's a frog. And Brian's a frog. That means that Mike is also a frog. And then Chris and them produce a frog. So that would be 3 frogs total. I should definitely check that at the end. It's a tricky one. Okay. How much time? It's been 20 minutes. Okay. Not bad. Okay. X squared plus y squared equals k squared. Integer values of k. The graphs do not intersect, so there should be no solution. X, y equals k. So y equals k over x. Okay. So x squared plus k squared over x squared equals k squared. X to the 4th plus k squared equals k squared x squared. X to the 4th minus k squared x squared plus k squared equals 0. So we want the discriminant to be less than 0. The discriminant equals this term squared, k to the 4th minus 4 times k squared. That must be less than 0. K squared times k squared minus 4, which equals k squared times k minus 2 times k plus 2 must be less than 0. I'll make a sign chart. 0 to negative 2. You plug in 1. This would be 1. This would be less than 0. Negative, this would be positive. You plug in 1. That'd be negative. If you plug in 3, positive, positive, positive. If you plug in negative 1, positive, negative, positive, that's negative. If you plug in negative 3, it would be positive, negative, negative. This is positive. So there's 2 values, 1, negative 1. There's 2 values. Non-degenerate triangle has integer side lengths. Okay, this looks maybe like triangle inequality or something. Definitely angle bisector. Okay. B, A, C. This is an angle bisector. D. AD is 8. DC is 3. So angle bisector, let's make this A and B. So 3A equals 8B. A over B equals 8 over 3. Okay. And we need triangle inequality to work. So if I just make A and B 8 and 3, if I make that 8, let's just make this 8K. And let's make this 3K. So K equals 1, then you have 8, 11, 3. This doesn't work, triangle inequality. K equals 2, 16, 11, 6. This works. 6 plus 11 is 17. That works. So the perimeter would be 6, 16 plus 17, which is 33. 7 plus 6 is 3, 33. That should work. 33. Okay. Wow, okay. 50 minutes. So, hey. Probability that it lands on heads is less than the probability that it lands on is less than 1/2. So let's let P be the probability of heads. P is less than 1/2. So it's 4 times. Probably equal number of heads and tails is 1/6. Okay. So you flip it. Now, okay, so p squared times p squared times 1 minus p squared times the number of ways to roll. You choose 2 of them, 2 out of the 4 rolls. That should be equal to 1/6. 4 choose 2, 4 times 3 over 2 times 1 equals 6. So p squared times 1 minus p squared equals 1 over 6 squared. P times 1 minus p equals 1 over 6. P minus p squared equals 1 over 6. So 0 equals p squared minus p plus 1 over 6. As for the probability, it lands on heads. P equals P equals 1 plus or minus the square root of 1 minus 2 over 3. That's 1/3 over 2, which equals 1 plus or minus square root of 1/3 over 2, which equals 1 plus or minus root 3 over 3 over 2. You multiply this by 3 over 3, that equals 3 plus or minus root 3 over 6. And p has to be less than 1/2 root 3 equals 1.7. So you want the minus, obviously. So it's 3 minus root 3 over 6. That's D. Okay. You pick. Okay, still like 50 minutes. Okay. 1 through 9, and you randomly arrange them to form a 3-digit number. You pick 3 numbers from a set 1 through 8, descending order, to form a 3-digit number. Okay, so you form a 3-digit number, and you form 2 3-digit numbers. So basically you make a 3-digit number from this, make a 3-digit from this, and you want this one to be larger than this one. That has a 9. So if you, okay, it's descending order. Okay, so any 3 digits will have 1 digit. So if you pick a 9 in any way, then you automatically win. So let's do casework. If you pick a 9 with a 9, that means you instantly win. The probability you pick a 9 is you pick one number 9, 2 other random numbers, and over total number, which is 8 times 7 over 2 divided by 9 times 7. 9 times 8 times 7 over 3 times 2. This equals 4. So this is 28 over 4, 3 over 12 times 7. That is 4, so that equals 1/3. If you pick a 9 and without a 9, okay, so first the probability that you don't pick a 9 is 1 minus 1/3, that's 2/3. Then, okay, so if you pick, you're picking a random number from this set, or you're picking 3 random numbers. So either this number, one number you pick could be greater, or they're the same number. Okay. So if you pick the same number, then there's no, it has to be greater than, right? And in every other case, you will have 2 different numbers. One is larger than the other, and half of them will be the larger number. Half of them will be with where b is the larger number. So first you need to find p of same. So probably you pick the same number is you pick some random number. Okay, so you have some number, you pick that number first. Is that right? Okay, no, let's not do that. It's 8 choose 3. These are the possible numbers you pick, and over the total, because they both pick 8 choose 3. Right. Okay, so this would be 1 over 8 times 7 times 6 over 3 times 2 times 1. That's 1 over 56. Okay. So P of the same is 1 over 56, so we want minus P over 2, which equals 55 over 56 times 2, which equals 55 over 112. That's the total probability, so we want 1/3 plus 55 over 112. Okay. Is that divisible by 3? No. Oh, no, times 2/3. Oh, that's a close one. Okay. That's 56. Okay. 55 over 3 times 56. Okay. So 1/3 plus 55 over 3 times 56. 56. So that would equal 111 over 3 times 56. That sums to 3. So 111 over 3 is 37 over 56. An answer choice. Okay, good. I should check that one. I sort of rushed through that one. I'm not sure. Okay. Okay. Just look at this. Okay. Equally angular hexagon. 3 of the lengths are 1, and 3 of them are R. Okay, so it's like 1, R, 1, R, 1, R. Okay, 1, 1, 1, R, R, R. So A, B, C, D, E, F. Right, CD is 1. Oh, okay. Camera's falling. Okay, that looks good. Okay. Okay, wait, let me just adjust this. Wasting time. Making time, I got 45 minutes. Okay. The area of ACE. ACE, this triangle. The area of that triangle is 170. Is 70% of the hexagon. So it's an equilateral triangle, right? This is 120 degrees, this is 120. 1 plus R, 1 plus R, these are all the same. These are all 120. Okay, that's a nice thing. I guess I could find this one. Love cosines. It's the area of the whole hexagon. It would just be this plus 3 times these. Okay, so let's just make this, call this area M, N, let's call this area M. So first, AC equals, AC squared is 1 squared plus R squared minus 2R cosine of 120 degrees. Cosine of 120 is negative 1/2. Negative 1/2. R squared plus R plus 1. So right. Seems right. Okay, so AC is that. And to the area, M equals AC squared times root 3 over 4. Okay, so N, I can do the law of signs. It's 1/2 times R times 1 times sine of 120 degrees equals r over 2 times sine of 120 is root 3 over 2. Root 3 over 4. Okay. So that means that m, that is 7/10 of the whole area, which is m plus 3n. 10m equals 7m plus 21n. 3m equals 21n. M equals 7n. Okay, I'm gonna need more paper. Okay. Let me get more paper. Okay. I got that m equals 7n. M equals AC squared root 3 over 4 equals R root 3 over 4. R, these cancel. AC squared equals R. R squared. Oh my goodness, I forgot the 7. 7. Okay. Equals 7R. R squared plus R plus 1 equals 6. 7R. R squared minus 6R plus 1 equals 0. So that means that R, I have to find some of the values. Okay, some of them might not be real though. Let me check. R equal, discriminant is 36 minus 4 plus 1, which is square root of 32. Okay, that's greater than 0. So both values are real. So that means they both work. Sum is 6. That's my guess, at least. Okay. The path. 16-step path. I think there was a problem like this. H1t. Okay. So negative 4, 0. You got this big square. Negative 4. 4, 4. 4, negative 4. Negative 4, 4. And it's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there's a square here. 2 by 2 by 2 square. 2 by 2 square. This is an important square, and we want, this is 2, 2, negative 2, 2 negative 2. I know the rest. Okay, you want it such that all the paths are outside of the boundary or on the boundary. Okay, so that means that it has to I could complementary count, or it has to go up or to the right. So if you go here, if you go on this point, that means that you couldn't have gone through the square, because you can only have gone through this rectangle. And then from here you can't go past the square. Okay. So that's the same with this point. This point. Negative 3, 3. If you go through this, you can't go through. Okay. So it's just you go through these 3 points. And the same here, you reflect it by 2. Okay, yeah, because you reflect it over, it's the same thing. So 2 times, and path from here to there is This is negative 2, 2. So this would be 2, and this would be 6. So 8 choose 2 squared, or no, 8 choose 2 times 1, 2, 1, 2, 2. Oh, that's also 6, yeah. So 8 choose 2 squared plus, I think this is also squared, this is also squared. This is 1, and this is 6 plus, oh, this is 4 plus 3, 1 plus 7, that's 8. Okay, 8 choose 1 squared plus, and it's just going straight all the way, 8 choose 0 squared. 2 times 8 times 7 over 2 squared plus, how much time do I have? 35 minutes. This is 64. This is 1. This is 4. I want 28 squared. Are these numbers big? Yeah, these numbers are really big. Plus 64 plus 1. Okay, 28 squared is okay, let me just do it. That's 30 minus 2 squared, which equals 900 minus plus 4 minus 2 times 30 times 2. 904 minus 4 times 30 is 120. So you subtract 20, 884 minus 100, 784. Okay, let me just check too, just make sure. 8 times 8 is 64, 16, 22, 8 times 2 is 16, times 2 is 4, 5. 4, 8, 7, that looks good. Okay. Well, this is actually a pretty bad computation. Plus 65. 9, 8 plus 4 is 14. 849 times 2. It looks like this. Let me check. That equals 16. Multiplied by 2 is 1600 plus 98. 18. Wow, really good actually on time. Oh, this might be really good actually. This page is done. Okay, these are where it starts to get hard. 2010 boxes. 1 is less than or equal to k is less than or equal to 2010. In the K position, you have K white marbles. So each of these will have 1 red, 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 and this will have K, 2K. Oh no, this will just have like 1, 2, 3, 4, 5. Okay. So that means that. Okay, and you pick from the first box. You draw from every other box until you draw a red marble. Probably you stop after drawing N marbles. Okay, so probably stop at first marble is oh, I think I did this wrong. Yeah. So in the first box you have 1 red, 1 white. So that's just would be probably they pick white. Or probably they pick red here. Just 1/2. P2 would be the probability that first you pick white. Then in the second box there are 2 white, 1 red. So in this one you want to pick red here, so 1/3, 1/6. P3. First you pick that row. This one. Then now you want to pick a white here. And then you have 3 white, 1 red. You want the red. 1/4. This cancels. Okay, wait. P4. And, oh, because, okay, so these will always end up canceling. And this will be 1/5. Right, because 4th box, 4 white, 1 red. So yeah, 1/5. Okay. So, so it looks like it's 1 over n times 1 over n plus 1. Does that work here? Oh, it even works for P1. Yeah. Yeah, that seems right, because all of these will keep adding up. These will also keep adding up. They'll cancel. Okay. So we want, that's 1 over n to n plus 1. P of n, which equals, that must be less than 1 over 210. Okay, so 2025 is 45 squared. So the answer choices is definitely going to be like 45. These numbers are way too big. Other numbers are too big. It's about 1 over n squared, so it's probably 45. I should probably check that later at the end. Okay. If integer a sequence a1 is b1 is 1 is less than a2 is less than or equal to b2. Arithmetic sequences. And some number in the sequence will have to equal 2010. Okay. Okay, we have 30 minutes, so that looks good. Heading into the final 5. No, final 6. It is. So these have to be integers. So, okay, the first 2010 is 10 times 201. That divides 3. 60 plus 21. So 60 plus 7, 67. 67 is prime. Okay. So, okay, so you can have like 1, 2010. Oh, this is 2 times 5. You could have 2. 2010 over 2 is 1005. You could have 3. Where's Bashy? Oh god. If this term is 3, this term is 10 times, this is 670. 5. 6 times 67. 7 times 5, so 335 plus 67. These aren't really important actually. And what do we want? We want such that 8n times bn, and you want to maximize n. So basically you want to jump by, well, can you just make this 1? Oh, because this has to be greater than 1. Okay, so that means that the common difference for A has to be greater than 1, and same with B, obviously. So A2 is less than or equal to B. Okay, so this is a smaller one, and this one will jump by 1, so this one will jump by something greater than 1. So let me just find the possible sequences. 6, 10, 15, 30, and after that, I think it gets bigger actually, because next it'll be 67, right? This should be 30, which is that, and then 67, so The next biggest is just 67. So, and this would be 30, so that means you have to go to this. Okay. So, I could just do them by one by one. So, okay, so the answer choices are 67, oh, let me just go backwards. 134. Right, 60 times 2, 7, okay. Oh, God, this is bad. You take out the 10, is 201. And this would be 67 times 5. 335. Okay, this is 2. 0 4 402. Okay, so we just have to find which one of these would actually work. So this is the A part, AN, this is BN. So this can't work, obviously. For this one, that means that AN would equal 1. We jump by ones, and it's just not even an answer choice. Okay, so what else? This one would mean that, let me get another piece of paper. This is a huge, bashy problem. Okay. So let me just put this on top, actually. So, let's see. This is 3. That, and this is 670. That means that n equals 2. So, that would mean that you add 2. Or this would be n equals 3. And this term would be like 69. If you go by ones. And that divides 3. It's something. It divides 3. So 3 works. Let's do 5. 5, 4, 2. So this would be 4. This would be 401. Does that divide? That doesn't divide 4. You could also jump by 2s, I guess. 1 plus 2 plus 2. Yeah. So that means this would be n equals 3. Alright. This would be 3, and this would be still 401. That divide 3? No. Yeah, I don't think it could be 5. 6. Okay, 6. That means either 5. N could either be 5 or 1. Or sorry, D could either be 5 or 1. And this would mean n equals 1 or 5. So I don't think, is that an answer choice? No, so it's just not that. Okay, so 10 means you have 9, so that means you jump by 3 or 1. And that means that you jump by, it means n would either be 3 or 9. Or 8, sorry. Yeah, you go from 1 to 9. That would be, oh no, that's 9. That's 9 jumps. Or 3. No. No. 4. 2 or 4. Because you start from 1 and you jump. So you want to get to 8. And those are definitely not answer choices. 8 is an answer choice, so I can check 8. Okay, so 9 minus 1, that would be 8. So that means that your jumps, what's the other factor? Oh wait, no, I'm being dumb. I'm being dumb. Is this 10? Number's 10. So that means that you have to make a jump. You have to go to 9. 1 plus 9. So 9 would either be you have to jump to 3 or jumps of 1. Or jumps of 9, but that's not his choice. And we already found 3, so. Yeah, this is not even an answer choice. Why am I doing this? 15. Okay. So that means that you do 1, that's 1 plus 14. That's 134. So this is either 2 jumps of 7, or just jumping by 1. Is that even an answer choice? I don't think so. Wait, actually, I think I screwed up some more. This is not 3. This is 2. Oh, if you have 3, then jumps would be 2. Yeah, this 3 doesn't work. I don't know why. I should have checked. I should recheck these though. I checked this one. Oh, let me just finish this first. You could do 2 times 7. So that means n would be 8. Yeah, we should check this. Okay, 134 minus 1 is 133. And if that divides 7, then we win. Okay, so this would be 1, 63. That's not, that works. Okay, so n equals 8 works. Okay, that's really good actually. 14 is not an answer choice. I think this one is golden actually, and these other ones are just so massive they don't make any sense. 8 works. Okay, this one definitely warrants a check at the end. Wow, that actually took so long. Okay, I have 15 minutes left. Okay, I might just keep going. So right now this would be 126, assuming I get everything right. Or no, 127.5. It's respectable, I guess. Okay, got polynomial. You just call p of x. Above the line, except it intersects at 3 values. Okay, so the difference is x6 plus 10, x5 minus 29, x to 4th. Oh my goodness, I'm screwing myself over with the signs. Minus 4x cubed plus ax squared minus bx minus c equals 0. And px, should be always greater than 0, because it never goes below. So it has three roots. It intersects 0 only 3 times. 6. So it has 3 double roots. Yeah. So okay. So the roots are p, q, r. So you have x minus p squared. Let me just sit more comfortably. X minus p squared, x minus q squared, x minus r squared. That equals p of x. Okay, I can use Vieta. Okay, I should try to. I want to solve for p, q, and r. So let me just say d of x equals x minus p, x minus q, x minus r. So you want the sum of the roots or whatever, you need to find the polynomial. Okay, so let's let sigma 1 be p plus q plus r. Sigma 2 will be PQ plus QR plus BR. Sigma 3 will be PQR. Okay, so sigma 1, big sigma 1 for g of x will be 2p plus 2q plus 2r, which equals 10 over negative 10, negative 10 over 1. That equals 10. So sigma 1 equals p plus q plus r equals 5. Okay, equals 5. Okay, so for this one,